work, energy, and power. Three concepts in physics we need to know about. Okay, first of all, we are going to take this concept one after the other. We start with what? Work. Okay, work is said to be done when a force is applied to a body and the body move in the direction of the force. That is what? Work done. When a force applied to a body and the body move in the direction of what? The force. So we said work is what? Done. In other words, work done is the product of what? Force. Work done is equals to what? The product of what? Force times what? Distance. Distance move in the direction of the force. That's what distance what? Move in the direction of the force. That is for what? Work done. For example, I'm pushing a vehicle and the vehicle is moving. That's work done. Because why? I apply force and there is what? The force create a what? A distance. That is what? Work done. There must be what? Force first and what? Distance. What if I'm pushing a fence now? A walk, pushing a fence. A walk. Is there work done? No, because there is no what? Distance. That is what? There is force, but no distance. What is the distance? Distance is what? Zero. Zero times anything is what? Zero. No work done. There must be what? Force and what? Distance for work to be done. So therefore, work done is equals to what? Force times what? Distance. There are other cases where we say a falling body, for instance, a body coming down due to what? Gravity under free fall, falling body. So we can say that work done is also what? Weight times what? Height. The body fall down from a what? A height, no longer distance now, from a height. And what brought the body down? Weight, the weight of the body. And weight is also what? Force. So therefore, we can also say that work done is what? mgh. Because weight is what? Mass times acceleration due to gravity. And this is the what? The distance, which is the height. mgh. So this is also what? Work done. So we can say that work done, for instance, this is the load. The load. Let's say this is the ground floor. I call this load. Why this is what? Force. Let's say the load was here before. Was here before. And due to what? Force. Now the load is here. The load move in the direction of the what? Force. Move in the direction of the what? Force. Because the force is going towards the what? The eastern direction. So the load move in the direction of the what? Force. And then we say this is what? Work done. Work is what? Done. There is what? Force and there is what? Distance. All right, let us consider other cases of work done. What if this force is inclined from an angle? Let us say this is the word load. This is the load. Please pay attention. This is the ground floor. Ground floor, and this is the force. The force is what? Inclined. This is the force. That is the net force. Inclined. From an angle. Right here, in this first example, the force is what? Basically at the what? The horizontal. That's the horizontal force. And the body move to the horizontal what? Direction. Now, what if this force is what? Inclined. It looks as if you are pulling the what? The load. This is the what? The load. Look as if you are pulling the what? The load. The force is no longer directly towards the load now. The force is now what? Inclined, forming an angle. What will now be the what? Work done. We need to consider the angle. And the body move move, that is creating a what? A distance. The body move. Now, where did the body move to? The body moved to the what? The horizontal direction. But the force, the direction of the force, the direction of the resultant force is what? Is inclined. And the body moves to the what? Horizontal what? Direction. That is, we need to consider what? The horizontal force. That is the force here. Consider the horizontal force. The horizontal force, that's take the what? The x-axis. This is the what? The horizontal force. We need to consider the horizontal force because the body move to the what? Horizontal. Work is said to be done. Don't forget the definition. Work is said to be done when a force applied to a body and the body move in the direction of the what? Force. Which direction did the body move to? Move to the what? The x and the x direction, which is the what? The horizontal force. So we need to consider this horizontal force. Now, how do we get this horizontal force? Remember, first of all, this is more like a triangle. If I have a triangle like this is my what? Hypotenuse. This is the angle. And I'm looking for this side. This is the what? The adjacent. The adjacent. I am looking for the what? The adjacent side. Remember, socatoire. Socatoire. Which string function do I need to use to get the what? The adjacent? I use what? Cos. So therefore, cos theta is equals to what? The hypotenuse over what? The adjacent. Isn't it? Okay. That is what? No, is what? Adjacent. Sorry. This is what? Adjacent over what? Hypotenuse. Now, if I make the adjacent side, I'm looking for the adjacent side, if I make it subject formula, the adjacent is equals to what? Hypotenuse cos what? Theta. And right here, what is the what? If we look at this, I'm looking for this side, isn't it? The adjacent is what? Hypotenuse cos. The adjacent side is, I'm looking for the adjacent side, is what? Hypotenuse cos what? Theta. The adjacent side is what? Fx, isn't it? So therefore the force is what? Fx equals to what? What is this? The hypotenuse is what? F cos what? Theta. So what is work done? Work done is equals to what? Fx times what? The distance moved. So work done, and what is Fx? That's the adjacent side, is what? F cos what? Theta times what? The distance. Now this is what? The work done. When the force is what? Inclined. When the force is inclined, there's an what? An angle that is formed. All right, let us consider other cases. For example, now, what if the load is inclined? Right here, the force is inclined. What if the load is what? Inclined. Now, I have something like this. This is what? The load. And the load is coming down due to what? Force. Now, what will now be the work? The work done. The load is coming down. What will now be the work done? The load is what? Inclined, coming down. What will now be the work done? Now, first of all, which force is bringing this load down? Which force is bringing it down? Is the what? The vertical force. There's an angle right here. Is the what? The vertical force that is bringing it down. The vertical force is bringing the load down. Now we need to get the what? The vertical. Here is what? This is the horizontal Fx. Why this is the what? This is the horizontal Fx. Why this is the vertical F subscript what? Y. So the vertical force is bringing it what? Down. But the load is inclined. Don't forget that. That's why there's an angle here. No, don't forget this angle. The vertical force is bringing it what? Down. So we need to look for what? This side. Now, how do I get the what? The vertical force. How do I get the vertical force? Using what? So to get this vertical side, I'm using what? Sine. In other words, this is what? Sine theta is equals to what? Opposite, which is what? Over what? Adjacent. That's the what? The net force. No. Opposite over what? Hypotenuse, which is the what? The net force. Hypotenuse. So I make the vertical subject formula is going to be for F sine what? Theta. So therefore the work done is equals to what? F subscript y times what? Distance. Don't forget the distance. So therefore work done is what? F sine theta times what? Distance. Now this is what work done. When the load is what? Inclined. But when the force is inclined, there's the work done. When the load is what? Inclined, there's the work done. We take cos, the force is inclined and the body moves to the horizontal. Take cos. Well, when the load is inclined, take what? Sine. Ladies and gentlemen, we have come to the end of this episode. In our next class, we are going to be taking questions on work done. Don't forget, we are treating this one after the other. They will move to energy and power. Subscribe to my YouTube channel. Thank you and God bless you.